Now, all right. This is a tall order as it stands. Now, practice test. It's total is 8 questions. I know that some of these have multiple parts to them, but there's 8 questions here. Goal today, we're going to do the first page, and then tomorrow we'll look at second page. So, if you kind of look at the problems I provided you, you're going to have a couple of trig problems. I would expect a sine or cosine for the first problem. I would expect a secant or cosecant for the next problem, and then a tangent or cotangent. So you got to be prepared. Number 4, it's gonna be some type of graph where you have to put the asymptotes in there, the where the curves are going. Draw a rough sketch. There can be a little bit of wiggle room by what your graph needs to look like. It just depends on how you're placing together the x-intercepts and stuff. Then number 5 will be the same thing. It'll be a second one. So maybe you didn't quite get one, you can at least get the second one. They'll be exactly the same number.
There's only 8 questions on this test.
Yes,
that means they're extremely high pointed.
Yes. Well, I mean, look at number 5. I mean, there's 6 things I'm looking at there. Right?
And that's just
4. Okay. All right. Number 6, doing limits. I will provide you a graph, and if you haven't noticed, these are all problems we've done the homework previously. I literally just pull them out. Number 7 and 8, you will be asked to find the limit as you approach infinity or negative infinity or a certain number. So I'll put that in there. So on number 7 and 8, we'll talk about those tomorrow. You're approaching infinity, positive infinity. But we'll kind of walk through that stuff. The goal today is to do the first 4. That's it. I want to get through the first 4. Well, if you have a little bit of time left at the end of class, you can work on your page 64 material if you have not turned that in already. That was based on your limit stuff. That's due tomorrow. Test this week is on Thursday. So I want to make sure that you guys all get a chance. Let's kind of walk through this. All right, let's look at number 1. It is a sine or cosine problem. Yours is a sine problem. Okay? So let's walk through each problem here. All right. So we're going to graph the following trig function. Now, let's just discuss before we start drawing this. Okay, shifting, amplitude, period. What are we looking at here? What is it doing?
It is shifting 10.
Okay, negative 10 shifted down. Okay, it shifted down, so we're starting below the origin.
What's 2 pi over 5?
What was that?
The amplitude is
2 pi over 5. No.
the amplitude.
The period, the frequency is 2 pi over 5. That's the frequency going out to the fourth marker.
Is 3.
And the amplitude is 3. And the negative sign means the graph is flipped over on its end.
It starts at the top.
So it starts, so this is sine, so it'll start and it will go down.
Are we going to have to know all 6?
So yes, because this will be a sine cosine problem first, sine or cosine, secant or cosecant, tangent or cotangent on the next one. There's 3 problems there, you can see them. So we want to be. Now, let's walk through this. So we're shifted down 10. So there's my negative 10 there. Now my amplitude says I'm going to go 3 above that and 3 below that. So what numbers am I actually going to hit? Negative 7 and negative 13. Those are the numbers I want to see. Yes, you do have to put those markers so I can see them. Now the 4 hash marks going across. The 4 hash marks across. I will eventually have to hit 2 pi over 5. I have to hit 2 pi over 5. So now that I've drawn my 2 pi over 5, I cut that number in half. Pi over 5, or 2 pi over 10. Cut that in half again. This is pi over 10.
3 pi.
Or that, and then, yeah, if I multiply by 3, that's 3 pi over 10.
We don't have to simplify, correct?
No, you can leave it 2 pi over 10 and 2 pi over 20 and 3 pi over 20. I don't care. And now, drawing this thing, because I have all my 4 markers for my period length, I have my amplitude, I have the shift down. I'm going to draw sine, and sine is negative on this one, so I'm going to go down first. So it is going down first to its lowest point, coming back up to 0, going up and to 0 again.
You know that will remove that marker, don't you?
Oh yeah, I'm being very careful.
That's my favorite color. It's lime green.
Yeah.
Purple. I love that color.
I like these colors. These are awesome. So, okay.
Yeah, brown, brown,
the Heller
purple,
family donated them.
neon.
So, appreciate it.
The Heller family did?
Yeah. So.
Yes, Heller.
Yeah.
Good job.
All right. Let's go to number 2.
Thank you, Wyatt.
Support your local Oh,
Okay.
hooker. Wait, the back of his shirt. It says support your
It's a
local.
tone sweatshirt.
Well, I'm gonna have to cut that one out.
Mr. Hank
Okay,
is not
stop
just-
making more work for me. All right,
Sorry.
number 2. Okay, all right, now, number 2.
Sexual harassment.
Hey, hold on.
Take it off.
Stop. Okay, all right. All right, number 2. This is a secant or cosecant problem. Obviously, I'm doing secant. So the goal was when I was doing these problems in class, you actually want to draw the reciprocal function, which is cosine, with the same numbers plugged in. And yeah, I'll probably have pi in there. I won't put pi. If I actually put pi in there, I was typing as fast as I could, and I didn't realize I just typed in pi. I didn't even put the symbol. All right, now this is the one that you have to draw first. And when you draw this, then after that, then I put the asymptotes in there, and then I draw what secant is doing. So this is the one where cosine is going to be very light, and I go off it. Now, on the test, I know I don't give you a lot of room, but you have to kind of optimize what you need to do. Like for me, I need to figure out where the period length is, like what my markers are. Then I need to figure out how it's shifted right and left, so I can put those markers in there. You do not have to simplify any
What's
markers.
like the letters for cosecant? C, SEC?
Yeah, CSC. Yeah,
What's
cosecant.
the last one?
Okay. What?
No, it's the opposite of the first one.
That's opposite of sine.
Oh, book.
Yeah. All right, now, cosine. So here's what I'm going to do first. I need to figure out how the 4 markers going across. Typically, I hit 2 pi. That's a normal thing, but I'm not. I have a number in front of my x I have to divide by. So I'm going to divide by 10.
Plus pi.
Then I'm going to cut that in half again. So this is 2 pi over 20. Cut that in half again. This is 2 pi over 40. Now, you do not have to simplify that. I'm doing this on purpose because I needed to figure out this spacing right here. This is the spacing that's important for me. It's the 2 pi over 40 or pi over 20, whatever you want to call it. I needed that space. That would have been the normal problem if it wasn't shifted right and left. Because you just take 2 pi and divide by the 10. So, all right, yeah, 1 pi over 20. Now, all right, so now what I'm going to do next is figure out how to start this thing. So, on my graph, the first marker here, I need to figure out where the starting point is. I'm not at 0, 0 anymore. So if you don't want to put this origin in there, that's fine. I'm not at 0, 0. In fact, the starting point, I have to take whatever's in the parenthesis, and I have to set it equal to 0 and figure out where it shifted. And so if I subtract that over, you're right, this is negative pi over 10. As I divide, so negative pi over 10. That's actually my starting point. Yep. Yeah, is that what you're asking? Yeah. So that's my starting point. So this is negative pi over 10. That's where I'm starting. And I'm going to put my 4 hash marks after it. So imagine that's your origin. And so when you're drawing this, I would usually have this graph off to the right. I need to go 4 hash marks to the right. Because wherever you start, you have 4 hash marks after it. Now, that was the right and left motion, right? I shifted over negative pi over 10. The 4 hash marks, how I find them, is I just add the 2 pi over 40. So I'm going to add, so this is negative pi over 10. I have to add 2 pi over 40. That gets me to the next marker. And no, you do not have to simplify that. Then I do it again. Negative pi over 10. I add another 2 pi over 40. So that's 4 pi over 40. Because I'm adding another 2 pi over 40. So when I add another 2 pi, that's 4 pi's now. And then I do it again. And so now I'm going to be at negative 10, or negative pi over 10, and I'll be adding 6 pi over 40. Because I'm adding 2 pi over 40s every single time, and that just keeps adding to the top. And notice I'm not finding common denominators. If you can't see those markers, sorry, here's what they are, really big. The next one is this. 2 pi over 40. That was adding my spacing, so that would have been the next marker down the road. So that was the first mark, so I added the 2 pi over 40. And then the next one, it was adding another 2 pi over 40, so it's 4 pi over 40. So that's been the next marker, is this.
It starts at 1. And it goes up.
Yeah, so you're absolutely right. So the marker up and down, this is 1. And my hash mark's going this way for my amplitude. So I was shifted up 1. My amplitude is going what, up 3 and down 3.
4 and -2.
So this is 4, and you're absolutely right, that is -2. 1, 2, 3.
Secant what's the arrows?
Yeah.
Right?
Yeah, we're gonna have to draw the asymptotes and everything. Yeah, you're right. So, okay, so what I'm drawing here first, I'm gonna draw this very lightly. I have to draw a cosine, because that's what I showed you. If I draw a cosine first and it's negative, so I have to actually flip this thing over. I'm gonna draw a cosine first, and then after I draw a cosine, then I can figure out where cosecant's going, or sorry, secant. So, cosine's doing this. Starting here, it's going up to its low point, and then it's going to work its way back down to its lowest point there. All right. So that's doing cosine like flipped upside down. Now that I have cosine drawn, again, this would be really light. This isn't my final drawing. This would be like just a really rough sketch of what I'm drawing here. Anytime I hit the origin line, like right in the middle, I have to put an asymptote right there. So I do have an asymptote. And I have an asymptote right here, because that's where my cosine graph hit the origin line. And then my graph will go the opposite
How do you
direction.
know where it hit the origin then?
Because it's the line in the middle. That line in the middle. Anywhere my graph was hitting that, that's where I put the asymptote.
Oh.
That's for secant and cosecant. You have to do the same thing. And now all I have to do is draw my graph going the opposite direction. So if cosine was going up, secant goes down this way. And if this thing's going downwards like a U shape, now I'm going up like a U shape. And over here, if this thing's going up, I'm going to go down this direction. So the part in red is the graph you should be drawing. Question?
This is a pain.
I can draw them, it's just the number part.
Here, I'm gonna get rid of my
Mine's the opposite. I'm gonna have a hard time remembering which one's arrows and which one's not.
Cranked it out down there?
Ew.
I got in trouble for that.
Okay.
Is this your next?
Next.
Yeah, just move on to the
Let's
next.
do the cops. Axie
Bro,
cop.
that was opposite of cosine. I thought that was opposite of sine.
Don't go sign you, Ryan.
Oh.
Jorge.
I'm frustrated.
All right. Moving on.
You call him a hooker.
I was reading this.
All right.
Small
You can probably get
business.
up. You can probably get up.
Okay.
Let's
All right.
go.
3. Okay. Cotangent. Cotangent is its own beast. Same with tangent. These you don't have to go off of anything and draw asymptotes. You have asymptotes, but it doesn't require that it's anywhere specifically. So cotangent. Okay, this one's been shifted right or left. It does have a new period length. Normal cotangent would go up to pi. So I have to divide by the number in front of x. So this is pi over 2. I cut that in half. So that's pi over 4. Cut in half again. Pi over 8. This is the spacing for cotangent. Cotangent isn't like tangent where it's centered over the origin. You have it like shifted over to the right. So my spacing is actually pi over 8 for this cotangent graph. That's my spacing to get to those markers. Again, cotangent and tangent normally go out to pi, not 2 pi. So then you have to divide by the number in front of x. So it's pi normally, divided by the number in front of x, cut in half, right? So my spacing is pi over 8. Now the shifting right and left, my starting point is 2x minus 3. Set that equal to 0. Add that across, divide by 2. So 3 over 2, so that's 1.5. 1.5 or whatever it is. So the idea is that that's my starting point and it's over to the right. So my graph is going to look something like this. So I don't really need this. It's going to be at 1.5 this way. And you have to put your 4 hash marks going this way for cotangent. Tangent would be centered over it. But I'm going 4 hash marks that way. And my spacing is pi over 8. So I'm going to take the 1.5 and add pi over 8. Add a pi over 8 again. So that's now 2 pi over 8s. Add another one, so this is now 3 pi over 8s. And add another one, so this is now 4 pi over 8s. And yes, I know they'll simplify, I just don't care to. That's the spacing, because again, cotangents always going to the right. It's 4 hash marks after the starting point, going that way. It has been shifted just up and down 0. What is my amplitude on this one?
1.
1 and -1, because it's not been, the amplitude isn't affected. Now, the only thing that's goofy on mine is cotangent is actually flipped. It's negative. So typically, cotangent starts up here and kind of works its way down and goes down to the bottom. Well, now it's going to be flipped over. So it's actually going to look like this. So it's going to have the asymptotes on the outsides, and that's how tangent and cotangent both work. I'm going to start up here now, because typically it was down there, but I'm negative, so I have to flip it over. It's going to hit the first marker at 1, go through 0, go to the next marker, and then down this direction. So it's going to look something like that.
There's actually a positive slope when it's negative.
Yeah, because cotangent typically goes the opposite direction. It usually goes this way. Yeah, it usually has negatives a little bit, right?
You're a genius, Isaac.
I don't know how to do this.
He's some.
I'm just looking
I
straight
know.
line.
I look like a line with like a cousin.
Wait, what does the tangent look like?
Tangent, it's over the origin. So it's right over the origin like this, and it goes this way.
So it's got the same.
Yeah,
Thing
the
going
only
on.
difference is you're not going 4 hash marks this way. You're
Yeah.
going 2 and 2.
Yeah. Okay.
So,
It's like you're zooming in almost.
Yeah.
It's not
So that's a regular tangent?
I messed that up.
That's 10.
That one,
that's
so if
tangent.
it was negative, it starts up.
Yeah, so it would be up here and it would work its way down.
Tangent.
And that's a negative one,
Yeah.
so this one's positive.
That's a negative.
That's a
cotangent,
negative cotangent,
Yeah.
Which is a positive tangent.
which is a positive tangent. Inversely related, I got it.
Yes.
Just like.
Whoa. So tangent positive slope is normal. So tangent positive is positive, cotangent positive is negative. That's what I gotta know.
Ooh, that's a weird way to think of it, yes. I followed that somehow. Okay, all right, let's go to the last one on the first page.
No, Ford.
But,
Hit it.
Okay.
Yeah.
somebody
The
said
last
my name. Who was
one? Is
it?
this our last one?
Last one today.
Ward.
Sure.
Okay, so you know how Newton discovered gravity by an apple falling out of a tree, right?
Yeah, very, very Hollywood picturesque. Yes.
Okay.
Right.
Nobody ruin it for me. Okay. So, and you know how that there's measurements, as in Newton is like a force of measurement?
Yes, they gave him that honor when they were naming it later.
Guess
I
how
guess.
much a Newton is? Like how much it like weighs, or how much
Like
force
how
it
much
is.
force that is?
Yeah,
1 kilogram worth of per gravity per.
an apple's worth. It's like the same approximately.
Is that 1 kilogram they weigh this?
I guess.
Apple?
Like 0.225 pounds, something like that.
Is that what it is? So it's,
It's approximately the weight of an apple. That blew my mind
Big
today.
kind of cool. I didn't know that.
That blew my mind wide open.
I like
had
it.
no chance.
So that's the one thing you learned in he
Jared's
right
smart.
after.
I like that. I like the history of it.
This is kind of chill.
See, I'm a man. I'm a man for the explanation.
Ward, what's your Apple Watch fan look like today?
About a Newton.
Ah, matching fan.
Okay. All right. So I got a bunch of the new ones, so I'm trying them out. See if I like them.
Are they like the
The
weird, like,
yeah, the solo
like it's
loops.
like silicone?
Yeah.
I wanna get
It's a
a
good one, it's a good one.
So
Do they stay on as well?
yeah, they're super nice. I like them way more.
I like the one that you can like.
It's so dumb.
Still got the old
So
one.
all right.
I like the magnet.
Now, okay. All
Do you
right.
slide on like a bracelet
The
though,
magnet.
or do you strap on?
Strap. No, you strap.
So they slide on like a
Like
bracelet.
the one like this.
Okay, yeah.
Okay. All right. End behavior, symmetry, x-intercepts, y-intercepts, horizontal, vertical asymptotes. How do we do it on number 4? What do we do? Let's say find x-intercepts. What do we do?
Try.
Factor.
Factor what? Top or bottom?
Top.
Top. Okay, top. We factor the top. Here we go.
All I know how to do.
X plus 4, x plus
I
1.
would've made those blue ones and some-
Okay, so what are my x-intercepts?
-1, -4.
-1, -4. So boom and boom. I might make that graph a little bit larger.
That's how I'm gonna remember.
I'm just gonna make it I'm gonna try to make it fit that little space that I have at the very bottom of the page. I just put it together and I'll adjust it. I'll make it a little bit better looking. All right.
We're gonna need a little more space for this cotangent tangent stuff
Okay,
too.
that's fine.
So
So make it like a 4-page
Is it x
test.
plus 2, x minus 2 for the bottom?
Yeah.
Okay, all right. So now that would be your vertical asymptotes, and you're absolutely right. So when we factor the bottom, that is x plus 2, x minus 2. So that is your vertical asymptotes, the bottom is. So I have a vertical asymptote at -2, and I have a vertical asymptote at +2. So on this picture, I have 3 distinct graphs going on.
Yes, sir.
Okay, now y-intercept. Let's do that part next.
0, 1.
So if I plug zeros into everything,
4.
if I plug zeros into everything, it'll be
Four.
-1.
That's what I said.
So,
4 over 4.
because here's what you get. When you plug zeros into all the x's, here's what you have. Plugging zeros into all the x's, I'll have 4 divided by -4, which is -1. So that'll be my y-intercept right there. Okay, you have to plug in both top and bottom. That was a mistake I made that first day we did it. Now, we kind of have those. I still need to look at symmetry is already thrown out. I know it's not symmetric because my x-intercepts aren't perfectly balanced, so I'm throwing that out. End behavior, we got to figure out the horizontal asymptotes, if it has any.
Does it? It's 1.
It is 1. Now, here's why. The powers matched. You have an x squared and an x squared. So the variables match. And since they match in powers, you will always go by whatever the leading number is divided.
1.
So in my case, it's a 1. That is because the x squares match, you divide the numbers that are out in front
So
of
they're
them.
gonna be points unless they are, like the asymptotes are gonna be when you plug in zeros.
So what codes?
For vertical anyway. For vertical.
What's the condition where there are no horizontal asymptotes?
That's where the top is bigger than the bottom.
Yeah.
By more than 1 degree.
I'm gonna have to memorize that.
I might have a clue on this for you.
And then if it's just
What?
one
So
that's
what's the
over.
end behavior?
So end behavior in mine, since we divided these x squares, we got 1. I have a horizontal asymptote at 1.
Wait,
So that means my end behavior, the tails, are gonna be centered around there. So they're gonna come in and like focus, it's almost like a
how do we
lemon.
get that +1 again?
Because you divide the top, since these degrees matched, you divide the front numbers, and that's where the horizontals end. That's if they match.
What's
If
a
they
slant
don't,
again?
that's where the top is bigger than the bottom by 1. If the bottom is too big, then it's always at 0. And if the top is bigger than the bottom by more than 1, it's nothing. You have
And
no.
so if the top is bigger than the bottom by 1, it's horizontally
It's like it's a slant. You have
And
to
it's-
divide.
that slope.
Yeah, it's whatever the slope is you draw it
From
there.
like, so if it was 3 over 2, it'd be 3.
Yeah, and you have to figure out where that to draw because you have to divide that to figure out where that line goes. Because you have to figure out where
It's
the
not over the origin?
It's not over the origin because it could be shifted up and down. That's why you have to long divide it and it actually tells you what that line is.
So when you do your end behavior on this, you don't have to like tell you what the end behavior actually
No,
is. You just
because
have to draw it.
doing the horizontal will tell you where it's going to be focused on.
So when I make my sketch, it's basically describing the end behavior.
Exactly.
So I don't need to like write anything.
No. These are just the things you got to make sure that you're covering in your picture. So if you want to make sure that maybe you can't see it very well, list them off up there. Like end behavior is going to be, tails going to be like, are going to be approaching 1. The symmetry is no symmetry. X-intercepts could be -4, -1. Maybe your graph looks really bad. You can list them out up here, so that way you're getting your point still.
Okay, so I can say like approaching 1
Yeah, for end behavior.
and
What does this look like?
-2 and +2. So
For vertical asymptotes, yeah.
So
You
how
list those
many
out.
things do we have to draw?
How many?
3 drawings.
Those things?
No.
3 drawings.
Oh, you mean over the picture? 3. There's 3 pictures here. How I know that? The vertical asymptotes tell you where they're drawn. The vertical asymptotes separate how many drawings you have.
How'd you draw it, Eric?
So here's how I'm going to draw it. I think I got a sketch of it. Here it is.
So I did this one.
It's probably doing something like this.
No, these, my red back there.
It's probably doing something like that. I'm probably expecting this one to do something like this.
I thought I couldn't cross it.
You can cross the horizontals. Horizontals are permeable. They're not rigid like a vertical.
That's so dumb to me.
Well, the
It's just
other
because
ones
all we use horizontals for are to figure out where the tails on the outside go. That's all it's used for.
So the middle one doesn't matter.
The middle one doesn't matter.
But the other one.
The other ones do, because the other ones have to focus around it, because that's where the thing goes. Now over here, I'm probably above this graph like
For the
this.
one below it.
because there's no x-intercepts below it. So it had to be above it.
Well, and there's already one below.
Yeah, exactly. So, okay, there you go. Probably what my graph looks like, really close.
So if the bottom highest exponent is bigger,
Then it's always at 0.
is that 0?
Is that 0?
Definitely thought
Okay, you know what your front page looks like. You know it's going to either be a sine or cosine problem in the number 1, it's going to be a secant or cosecant in number 2, a tangent or cotangent in number 3, and number 4 will be some type of graph, something like that you can do very quickly, something very simple looking.
You
that
long
you
divide it when it is greater than by 1 on the
on the top.
Can we
Greater.
just not have one of those just to help us out more?
Nah, I don't know about the next page because there's one on the next page. I don't even know if that's one.
Like on the test.
No, because he said he was not going to do continuous, and he did.
What are you talking about?
No, the last test.
The last test you said there wasn't going to be continuous. So you did it.
I should just not talk.
Definitely
He literally said, and I quote, there will not be a continuous one.
I don't know.
None of us learned how to do the formula.
What?
Because
This
You can throw it out.
I don't think anyone finished the test the first day. You do?
Just go plug it in.
Why?
Brandon didn't even, and
I didn't know you had that option.
I saw
What?
The first test that we had to do finish it the first day.
The study guide?
The only other test we took.
All right.
No, the
No.
test, the last test that we had.
Oh, no.